to Digital Signal Processing online lecture series. Myself, Rima Rawal from LG Institute of Engineering and Technology. Today's topic is examples on properties of discrete time system from the unit number 2, that is discrete time signals and system. Okay. Now in previous lecture we have seen the properties of discrete time system. There are 5 properties and we have seen the definitions of them, and we have seen the basic concept how to find whether the system are static or dynamic, time variant or invariant, linear or non-linear, causal or non-causal, or stable or unstable, right? We have seen all of these 5 properties basic. Now in today's lecture we are going to see some of the examples based on this. In example, you may ask to find any of this property, or it may happen that you are asked all of these properties to find for the discrete time system. Okay. Okay, so first consider the first example in which the question is check whether the following systems are number 1 static or dynamic, number 2 linear or non-linear, time variant or time invariant, causal or non-causal, and stable or unstable. Okay, so you are asked to find all of these properties to check, and here the data are, first one is y of n equals to the system function x of n plus x of n minus 1. Second, output system function y of n, that is equals to x of n plus 4x of n plus 1, and the third one is y of n equals to 3 into x of n. Okay, so now let's consider the first data, that is y of n equals to x of n plus x of n minus 1. Okay, so let's see the solution for that. We are going to check each and every property for this. The first property is we need to check whether it is static or dynamic. So as we have seen in previous lecture, a system is said to be static if it depends only on the present input, and whether it depends on present, past or future values, it will be a dynamic system, right? So here in this case, the output system function y of n depends at the present input as well as the past values of the input, right? So this system will be a dynamic system, right? So first answer is it is a dynamic system. Okay, now second property we need to check is whether the system is time variant or time invariant, right? So for that we need to perform 3 steps. Step number 1 is input is to be delayed by k sample, or delay the input by k sample. Input is to be delayed by k samples, and we will denote it as y of n comma k. That will be equals to, here the first input is x of n, so here it will be x of n minus k, and the second input is x of n minus 1, so it will be x of n minus 1 minus k, right? And now the second step, step number 2 is what? Replace n by n minus k. That means in the given system function, wherever the n is there, you need to replace it by n minus k, and we will denote it as y of n minus k. So here the first is x of n minus k plus x of, instead of n we will place n minus k. So here it will be n minus k minus 1. Okay. So now step 3 is to compare step 1 and step 2. That means to compare y of n comma k and y of n minus k. So as you can see, both of these are equal, right? This is also n minus 1 minus k. This we can also get n minus 1 minus k, right? So this both are equal. So here we can say that y of n comma k, that is equals to y of n minus k. And if both these are equal, we will call it time invariant system. That means with respect to time, it does not change, right? So this system is time invariant system. Okay. Now the third one, that means we need to check whether the system is linear or non-linear, right? So for that, step number 1, as we have seen in previous lecture, we need to check for superposition theorem. That means first of all we need to take individual signal and then add them, which will be called as y3 dash of n. That means first here we are going to consider the signal 1, that will be x1 of n plus x1 of n minus 1, right? This is signal number 1. Similarly, the individual input signal number 2 is given, which will be the same according to the function x2 of n plus x2 of n minus 1, right? So here we have considered two individual input signals. First will be denoted as x1 of n plus x1 of n minus 1, and the second signal will be x2 of n plus x2 of n minus 1, right? Now in step 2, we are going to consider the addition of this signal, and then we will apply to the system, which will be denoted as y3 dash of n. So what happens over here is we will combine this input and then apply to the output function. So we can say over here is x1 plus x2 of n plus x1 plus x2 of second function, that is n minus 1, right? So if we add these two terms, this will be x1 of n plus x2 of n plus x1 of n minus 1 plus x2 of n minus 1. Okay, so this will be x1 of n plus x2 of n plus x1 of n minus 1 plus x2 of n minus 1. Okay, now we need to compare this with the equation number of step 1, that is y3 dash of n. So as you can see, this is same, x1 of n plus x2 of n, that is x1 of n plus x2 of n plus x1 of n minus 1 plus x2 of n minus 1. Both are same. So the step 3 is what? Here y3 dash of n equals to y3 double dash of n. So here we can say the system is linear system, right? Okay. Now the next is what? Number 4, that is whether the system is causal or non-causal, right? So here we are writing the fourth, causal or non-causal. Now as we have seen, a system is said to be causal system if it depends on the present as well as on the past inputs, right? So here it depends on the present as well as on the past input values. So this system will be called as causal system. If it may include any of the future values, it will be non-causal system. Okay, so this is the causal system. And number 5, whether the system is stable or unstable, right? So in this system, what happens is, for any input values of n, if the output is finite value, that means if it satisfies the condition of bounded input, bounded output, this system will be called as stable system. And if for any input values, the output will be infinite, that means for finite value of the input signal, if output becomes infinite, this will be unstable system. So here, if I take n equals to 1, that means a finite value. This will give x of 1 plus x of 1 minus 1, that means x of 0. This will give a finite value. Similarly, if I take n equals to 10, that will give x of 10 plus x of 10 minus 1, that is x of 9. So for every finite value of input n, it will give the finite output value. So this system will be a stable system, okay, which satisfies the BIBO condition. Alright, so these are the answers for this. That means this system is dynamic system, it is time invariant system, it is linear, causal and stable. Okay, so these are the 5 properties which we are asked to check. Okay, now which is the next question? Next question is y of n, that is equals to x of n plus 4, x of n plus 1, right? So now we will see this example, y of n, that is equals to x of n plus 4 into x of n plus 1. So now second example, y of n equals to x of n plus 4 into x of n plus 1. Okay. So similarly, let's check the properties for this example. First one is to find whether the system is static or dynamic. So here, as you can see, the first term is only dependent on the present inputs, but the second term has the future values as well. So this system will be a dynamic system. Okay. Now second, that means whether the system is time variant or time invariant. So for that, step number 1 will be delay the input by k samples, delay the input by k samples. We will denote it as y of n comma k, that is equals to x of n minus k plus 4 into x of n plus 1 minus k. Okay. Step 2, replace n by n minus k, so that will give you y of n minus k, that is equals to x of n minus k plus 4 into x of n minus k plus 1, right? So here I have replaced n with n minus k. Now step number 3 is to check these two steps, that means y of n comma k and y of n minus k is equal or not. So as you can see, x of n minus k and this term both are equal. So we can say that y of n comma k equals to y of n minus k. So this system is time invariant system. Okay. Now the third is to check whether the system is linear or not. Okay. So for that, the step 1 is to find out y3 dash of n, that is equals to individual input, that means x1 of n plus 4 x1 of n plus 1 plus x2 of n plus 4 x2 of n plus 1. Alright, step number 2, that is y3 double dash of n, in which we are going to add the input signal and then we will give to the system function. So it will be x1 plus x2 of n function plus 4 into x1 plus x2 of n plus 1. Right? When we will multiply this, it will give us x1 of n plus x2 of n plus, it will give us what? 4x1 of n plus 1 plus 4x2 of n plus 1. Right? So when we'll compare these two equations, it will have all the terms similar. So the step 3 will be y3 dash of n, that is equals to y3 double dash of n. So the system is called as linear system. Okay. Now the fourth property is whether the system is causal or non-causal. So as you can see here, it depends on the present as well as on future inputs. Okay. So whenever the system has present, past as well as future values, okay, or else you can say any of the future values present, it will be our non-causal system. So this system is called as non-causal system. Okay. Then fifth, that is whether the system is stable or unstable. So if we consider over here n equals to 2, so y of 2 equals to what? X of 2 plus 4x of 2 plus 1, that is equals to 3, right? That means for the finite values of the input, it will give the finite values only. It will not give the infinite values, right? So this will be stable system. Okay. Now the next question is y of 3 equals to 3x of n. So now we will do this. Y of 3 equals to 3x of n. Okay. So the question is y of n equals to 3 into x of n. Okay, so for this again we check all the properties. First one, whether the system is static or dynamic. So here you have only x of n, that means it depends only on the present inputs as well. So this is called as static system. Okay, the next property is whether it's time variant or time invariant. So for that, step number 1 is we are going to delay the input by k samples. So we will get y of n comma k, that is equals to 3 into x of n minus k. Then step number 2, replace n by n minus k, and we will get y of n minus k, that will be 3 into x of n minus k. Again the same. So as this two are equal, step 3 will be y of n comma k, that is equals to y of n minus k. So the system is time invariant system. Okay. Now the next, number 3, that is to check whether it is linear or non-linear. Okay, so for that step 1 is to find out y3 dash of n, that is equals to individual input, that means 3 into x1 of n plus 3 into x2 of n. Okay. Now step 2, that is equals to y3 double dash of n, that is equals to 3 into, we are going to consider addition of this input, x1 plus x2 of n. So what it will give? 3x1 of n plus 3x2 of n. Okay, so this both are equal again. So step 3 will be y3 dash of n, that is equals to y3 double dash of n, both are equal, so the system is linear system. Okay. Now the fourth property is to check whether it is causal or non-causal. So according to causal system, it should depend on present or past values or the combination of that. It should not include any of the future values, otherwise it will be non-causal system. So as you can see in our example, only present values are there of the input, so this will be our causal system. Okay. Then fifth is to be stable. So at any input values of this, it depends only on that particular instant. Alright, so this system is stable system. Okay, so as you can see from here, this system is static system. That means first property. Then it is time invariant system, second property. Third, it is linear system. It is causal and stable. Okay, so these are the 5 properties of the example y of n equals to 3 into x of n. Okay, so now in next lectures we are going to see some variants of these examples. So we will see some more examples for this to check properties of this discrete time system. Okay. These are the references. Thank you for listening.